Hey there, welcome to Green Disruptors, the podcast where we talk about innovations in climate tech and how to scale those companies. I'm your host, Megan Kjar. Today's episode takes an unexpected turn into the world of race cars. This is definitely a topic I never thought I would be covering, but trust me, this has everything to do with the future of clean energy. I'm joined by Martin Popilka, founder of P1 Fuels, a company that's doing the unthinkable, decarbonizing some of the world's most demanding engines, from Formula One cars to vintage classics, without compromising on performance. So if you're a car person, this episode's for you. We talk about how synthetic fuels made from captured CO2 and renewable energy can power existing vehicles, reducing emissions without replacing an entire fleet, and decentralize energy production in a way that rivals microgrids. Whether you're an energy geek, climate tech founder, or just someone who drives a car, this episode will challenge your assumptions and offer a new way to think about decarbonization. I hope you enjoy. Hello, listeners. Welcome back to Green Disruptors. Today, we're going to talk about race cars. So, you may not think this is relevant to energy and climate, but it totally is. So, I'd like to welcome Martin here from P1 Fuels to tell us why this is an important topic.
Hey, Megan, great to be here. Thank you. Yeah, race cars, as you said, people don't associate that with climate change, but 5 years ago, we set out to decarbonize some of the most demanding engines on the planet. And, everyone said it can't be done. And we did. We decarbonized everything from Formula One cars to entire championships like the FIA World Rally Championship with fuels that just drop in, work, are completely green, no oil, just performance.
That's crazy. So, how did you personally, are you a big race car guy? How did you get involved with this?
I am a race car guy. Yeah, I used to race many ages ago, and this was kind of a personal mission for me to race without trace.
That's really cool. We've got a fun prop in the background if you're watching the video version, but
That's not my car.
I mean, just say sure. You don't have to say it's not, then people will assume that it's yours.
Not yet.
Not yet. There you go. Okay, so yeah, I mean that does sound like a big undertaking. It's like I wouldn't have thought of race cars. Usually people think of airline fuel maybe as being more relevant, but this is a big industry and a problem that needed to be solved. So tell us about kind of how that works and tell us about what you're doing in P1 to kind of roll this out.
Sure. Well, look, two things, right? Everyone talks about aviation fuel, and it's absolutely a problem that's going to, increase over time as more airlines, more aircraft hit the market. But transportation as such is about 20% of all greenhouse gas emissions globally. And out of that 20%, the majority of those emissions are from passenger cars. So not aviation, which is a mere
Yeah,
10%. So it's a huge problem. And race cars are a wonderful way of showcasing that those 1.4 billion cars that are on our roads today and aren't going anywhere in the next few decades have solutions to decarbonize. And, motorsport has taught us a lot. It basically allowed us to focus on what really matters in energy transition solutions, right? So energy density, radical reliable, making sure that you don't have to modify the engine. Because if you think of a Formula One car or high performance engines, you don't have that much space to modify and change
that's
these
a good
engines,
point.
and that's exactly what a normal car on the road is as well. Consumer purchased the car 20 years ago, 10 years ago, 5 years ago, and want to decarbonize by just switching the fuel. They can't change the injectors, right? They can't modify the ignition timing. So that's why, racing for us has been not only a great storytelling, but also really hardcore learnings in how to work with high performance engines.
Yeah, that makes sense. It's like you have what you have the space that you have, and there's people are not willing to compromise on performance in this. Something else that strikes me is like, I'm sure there's still a lot of resistance in the market to these alternative solutions, but people who are interested in racing in Formula One, these are car people. And so if you can convince them through their idols and through these beautiful cars that do amazing things, that's a pretty huge branding move.
Yeah, absolutely. I mean, we were so fortunate to get some amazing people on board, including four-time Formula One champion Sebastian Vettel, who used our fuel in his Formula One cars and was kind enough to promote the important work we're doing. showcase that if you can decarbonize a F1 car, you can do that. So yeah, it's great to have car people on board and to see that people from the broader, let's say, consumer group are taking the energy transition seriously. And it's not just EVs that will solve our pain points.
Yeah. So is this something that is transferable to just a regular vehicle that we
Yep,
all use every
absolutely.
day?
It is. It's transferable. Um, and we've proven that on and off with everything from historic cars, where we, for example, worked with Mercedes-Benz at the iconic Mille Miglia rally in
Yeah.
Italy. There's a car from the 90s, I believe, also ran without modification and with a certified 90% greenhouse gas reduction over fossil
Wow.
fuel.
So give me a little bit of the nitty-gritty science details. Like what is this fuel and how do you make it and where are you sourcing it?
Yeah, the absolutely valid questions. Synthetic fuels, as such, are made from waste CO2. So that CO2 can come either from industrial processes or from biomass. In our case, what we're trying to scale is CO2 captured at source, but also by direct air capture combined with renewable electricity to make a 100% synthetic hydrocarbon, in our case, gasoline.
Okay. Very cool.
So no oil feedstock. I guess,
Yeah.
it's making the fuel is not the problem. Actually, these technologies were developed as early as the 1920s in Germany. Germany faced a oil embargo. A gentleman called Fischer-Tropsch invented a process that takes coal, fossil coal, that is gasified and then converted into liquid. So that is basically a synthetic fuel. So these technologies have been around for ages. During the fuel shortage in the United States, ExxonMobil in the 70s has developed a methanol to gasoline is to make synthetic fuel. So we're not talking about, chemical processes that are completely crazy or unknown. It's more
So yeah,
about,
you haven't been buried in the lab for the last 20 years and
no, we haven't. This is science that exists, very much tangible. I think what set us apart is that, our fuels don't just work in the lab, they actually work at the racetrack. And that's a huge difference, right? If you don't have on race day, you don't have time to get it right. So it has to work from the first lap to the last. Otherwise, yeah, you lose the race.
yeah. So tell me about like what's the business model here? Like are you selling the fuel mostly to Formula One or like what does growth look like with a
Yeah,
company
good
like this?
question. So look, it's a bit complicated. So, we did a lot of great things in racing, but a lot of things didn't work. What worked in general is we had really fast iteration cycles to learn and collaborate with engineers, car manufacturers, and the wider, let's say, stakeholders. That kind of drove like a deep co-development process, which allowed us to make these fuels and deploy them quickly. A lot of things didn't work. And one of the main things is that what we learned is that these overly centralized systems. So when you have expensive demo facilities that are very high capex and centralized in one location, are basically impossible to scale. I mean, the further you have to deliver the fuel, the harder it is. There's so many disruptions in the global fuel supply chain. I mean, we spent sleepless nights making sure that fuel gets to Japan. We did Australia or New Zealand, everywhere. And that really, broke a lot of us.
It
First-
broke you in general.
Yeah, so global energy supply systems are challenging even on a small scale. And imagine what that then is on a larger scale, right? When you think about energy that we all need to live. So that
I mean,
taught us that.
are you shipping this in barrels just like standard oil?
Yeah, we were in barrels. So from 200-liter drums or 54 gallon barrels to smaller ones, depending on the application. And that's, yeah, getting a barrel from one side of the world to the other is not as easy as shipping it with DH.
Yeah. I have never seen UPS with oil barrels in there. Yeah.
Yeah, so
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 yeah, like what's
that's
the solution there?
so we pivoted. We basically decided that this legacy model of being vertically integrated, like running a small energy company that does everything from technology development, raw material sourcing, processing these raw materials, building the plant, managing inventory, shipping the fuels globally, getting the permits, doing health and safety, managing the customer relationship across markets is a game that's very hard to scale efficiently and quickly. After proving that the fuel works in racing, we decided that making it is not really a problem. I mean, case in point, it was done in the 20s, more or less, right? So the challenge is deploying it. And that's kind of where we are today with our new company, where our aim is to decentralize the production of synthetic fuels, not only gasoline, but various hydrocarbons required for the energy.
So like anywhere where they're making existing plants, like you can give them your formulas and then they would distribute that in their local area. Is that the idea?
It's a good question and kind of brings me to one of the topics I want to talk about. So, the energy transition, everyone talks about it as this magical thing that will occur. But what I kind of find that people don't really talk about is that it's not transitioning what we have been doing for decades into a more sustainable way, because it's more of a systems approach, right? So
Yeah.
what we're seeing is you can't just change the fuel in such a fragmented market and with all these developments going on. And what I'm trying to say is we're looking to change the status quo. And I don't think that the best way to do so is to stick to centralized, large legacy systems, because if there's anything that we've learned over the past 5 years is that new players are emerging across the energy value chain, whether that is electric suppliers looking into power to X solutions, whether that is mobility companies offering recharging. So when you think about energy, this kind of standard defined market segments will eventually blur and are already blurring. And so what we're going to do is we want to develop decentralized small production units that anyone can deploy to make fuel closer to where it's required, bypassing all the bottlenecks of global logistics, navigating these geopolitical choke points that we're seeing in 2025. That's that's the difference. I think
I
licensing.
mean, that makes sense because that just reminds me of people kind of going off grid and like the whole microgrid concept. It's like kind of the same idea, but with fuel.
Yeah, absolutely. And you look, you have regions today, think like Alaska or very remote regions, they're paying 3 to 6x for fossil fuel just because the centralized energy system has failed them, right? Most of the refineries in the United States are closing down. We have 10% less daily refining capacity in the last 5 years, with more than 3% to close by the end of this year alone. Majority of the oil refiners are exiting states like California, where the energy transition has made it very difficult for them to thrive. Yet, we're all dependent on liquid fuels. So this whole kind of shakeup is really an opportunity to design and deploy systems that enable local production closer to where consumers really need their energy.
So do you have some kind of hot spots in mind where that would be some good like initial rollout projects, or have those started already?
Not yet. So we have started just earlier this year. We are on track. We've identified some great projects with customers, but are not just yet ready to publicly announce them. But aim will be to really capitalize on market segments where you can reach fossil fuel cost parity today with the current TR levels of the technology and with the current feedstock costs. One of the things about the energy transition is, you know, green fuels come at a green premium. And that's great in racing, right? Where the market is very price elastic and, whether a Formula One team or a car manufacturer pays €3 a liter or 10 doesn't move the needle.
Yeah.
Market segments that are paying a premium and shouldn't have to.
So you're saying like this is an example of that. Like you could like is it going to be more cost effective once these systems are in place?
Absolutely. So if you think about, what's driving the cost of fossil fuels today, right? So if the refining capacity decreases, all new refineries are built in the Middle East and Asia, you're increasing logistics costs. When you think about the geopolitical state of the world today, you have so many choke points, whether it's the Panama Canal, whether it's the attacks at the Red Sea, whether it's Long Beach, port congestion, all that is
Yeah.
driving up logistics costs and uncertainty and price volatility. So, bypassing this, which is technically possible to make fuel closer to you, you cut costs.
Yeah. I mean, that makes total sense. Seems like a very logical solution. So,
Yeah.
I mean, obviously there's still a lot of hurdles to cross, but what does this look like in terms of like what problems do you need to solve right now to get to these next phases?
Wow, good question. So from the technology standpoint, I think we're more or less set to deliver on our targets before the end of this year. We're planning to have our first units ready next year. So on that perspective, I think we are more or less in a good state. One of the challenges that we're seeing is, and maybe just to talk a little bit about motorsport again, when you deploy new technologies in motorsport, everyone's in the same room. You have the regulator, you have the teams, you have the car manufacturers, you have the engineers, and you're solving a problem together very quickly in an integrated way. When you think about how the energy system looks, the policy is completely disconnected. Operators work in silos. So deploying systems thinking to decarbonizing the energy space is very challenging because you have to somehow find a way to integrate these very siloed, let's say, stakeholders. So I think that's our largest challenge because even if you think about legislation today, it still treats fuels in a different way than it should, right? So, for example, when you think about what is a zero emissions vehicle, right? So, according to the California legislation, that's electric vehicle. But is that to say that an electric vehicle doesn't have any CO2 emissions? No, that's not the case because
Because you have to
it's only
create the battery, you have to mine the metal.
yeah,
Yeah, like all of it.
exactly. So the measurement, the method is flawed, right? You're measuring at the tailpipe. So you're actually applying a method that was designed for combustion engines to qualify a completely different technology, right? So
Yeah,
that doesn't work. So I think really bridging these gaps and trying to navigate this in a very fruitful way is something that will be challenging, but also is super exciting because that
yeah,
gives way for opportunity.
totally. Yeah, well yeah, that's interesting because you would just assume if you have fuel in your name, like you're not being viewed in legislatures and those conversations in the same way that wind and solar are and electric vehicles, but like maybe you should be.
That's a great point. And look, you just mentioned wind and solar, right? Absolutely necessary, decarbonization pathways for our energy. Think about California, or Germany. There's so much wasted renewable electricity today. Like it's about a $50 billion problem annually. And states like California, in peak days, the grid cannot handle that amount of renewable electricity. So it's actually being offered to neighboring states, and they pay them take our renewables off of us because we cannot ingest it into the grid, right? So that's one kind of, again,
That's
siloed
crazy.
problem, right? And then on the other hand, you have the EVs that need that electricity that don't get it. And in the middle, you have, 250 million cars in the United States that are combustion. So again, like a lot of silos that need to be disrupted. Like you cannot view energy, electricity, mobility, liquid fuels in siloed ways.
Yeah. So who are your ideal partners and people that you're looking with to collaborate to make these more micro processing plants?
Yeah. So I would say that we're looking to partner with anyone who has access to excess renewables and waste carbon dioxide. So we were very fortunate, the previous company, the racing company, to actually connect with a lot of very large energy companies, grid companies, technology companies, and multinationals that are aware that the system will be changing and looking into ways of capitalizing on that. So currently, we're still predominantly focused on working with large multinational energy companies that, you know, distribution, deployment of such systems is their bread and butter. Ideally, my vision would be that these units can be deployed by companies that have never operated a refiner. So micro production units.
I love that. That's cool. So, I mean, are you mostly finding these people now by conferences, personal network? Like, what does that look like?
Well, just I think our previous network. So I don't really do
Excellent.
conferences.
Well, I mean, if you don't have to and you're finding the connections, then that's great. And you can't drive a race car around inside a conference, unfortunately. If you could, then you'd want to go. All right. Well, I mean, is there any action items you want to give listeners before we wrap up today?
Action items. I don't think it's my place to give anyone any action items, but um, maybe I'll leave like with the closing remark.
Yeah.
The world doesn't need another $500 million mega refinery in Asia. What we need is hundreds of thousands smaller decentralized units. I think that's kind of the overarching narrative of what we're trying to achieve.
And I think value and culture wise, people can get behind the autonomy of having this in your local community and knowing the people that run it and being able to see what's going on and knowing the environmental impacts on your direct community. Instead of there's so many things in our world where we just never see the other side of it. And that's part of the reason we've gotten into this mess.
Yeah, absolutely.
Well, thank you. This has been a fun conversation, and it's exciting to hear what you're doing, and it'll be definitely interesting to follow the progress in the coming year.
Awesome. Thank you so much for having me.
Yeah, my pleasure. If today's episode got your gears turning, pun always intended, be sure to check out P1 Fuels and to follow the exciting work Martin is doing to bring synthetic fuels closer to communities worldwide. If you're enjoying Green Disruptors, thank you. Take a moment to follow, rate, or share the show with someone who's passionate about climate innovation. And of course, until next time, stay curious, stay bold, and keep building a better future. This podcast is brought to you by Mountaintop Social Marketing, your growth partner in sustainability.